Go. As you can see, second project, power supply, is done now. It's finished. I just need to put this panel on this side, and that's it. So what I got here is explain. So I got the power switch here. As you can see here, you power on automatically. You can select either be on the power supply or the whole thing off, or you go into the charging mode down here, and then what you got to do, you can charge cell A or cell B. I mean the power supply A or power supply B. So if I go up, you can see here I got 6 cells. They're charging at the moment. Once they're all charged, the LED will turn into green. So that's 6 of them for rail A, and then I can go here and 6 for rail B. And then again they got the same thing here. And what I got over here, which is not showing at the moment, is the temp and the under voltage. So if that occurs, then the light will come on and it will trick the relay on, and then it will turn off into whatever cell that that's been tripped for. It will turn it off. At the moment everything is nice and dandy, so there's nothing going on. So that's that. So what I got here at the moment, as you can see, I've not in the power supply mode, so I'm charging and I get no output. Even though my output load switch is on, I get no output whatsoever because everything is off at the moment on the power supply. Okay, so what I got, if I gotta come out of charging mode and I go into the power supply mode, as you can see here, we got the same kind of setting as my previous power supply that I had. I had to change the voltmeters that I made. These ones that I made with the ICs that I made myself. Unfortunately, they had some grounding issue with the whole system that I was having, so I had to just resort into using these ones again, which is alright. It's not an issue. As you can see here, if I go up full scale here, 5 volt. If I turn the load on, as we go here, oh, I'm not connected. I got to connect to the scope. I was just trying to look at the noise on the output, which is nothing at the moment. As you can see here, I got 5 volt there. I don't know how good that shows. Let's put the light on. Where is the light on this thing? Oh, there we go. 5 volt. We're on 5 volt. So if I go up a scale, there we are, 7.5 volt, 7.5 volt. I go another up, 10 volt. We got 10 volt. And if I go full scale on the power supply, 1501, 1501, and then again, now I can select whatever voltage I want. I'm in the 15 volt scale, full scale basically of the power supply, so I can select whatever voltage I want. So if I come down now, I go to the 5 volt scale, then what I can do, I can go all the way obviously to 5 volt. There we go. So if I go up, I go 7.5 volts, so then I can come down to whatever voltage I want from 0 to 7.5. If I go up a bit, I can go for whatever voltage I want to 10 volt. As you can see there, 10 volt, I've got 10 volt here. Again, I got the same thing over here where I had with my previous power supply, where I can set the current that's been drawn or the current that I'm setting. As you can see here, I decided to up the current because I decided that the batteries that I had were capable of handling the current, so I've put the current into 1 amp. This one is 1 amp, the other power supply, the other rail is 1.5 amp, as you can see here. So this one's got, as you can see here, I got 5 volt, I got 7.5 volt, I got 10 volt, and I got 15 volt. On the second rail, what I got 5 volt again. If I go full scale, I got 5 volt. Ooh, where it is? I've got 10 volt, I got 12.5, and then I got 15. So this one does 12.5. This one doesn't do 12.5. I decided to just make it different, so if I needed something in between, then I can power them here. And as you can see here, this one's got goes up to 1.5 amp. This one goes up to 1 amp. So you can see here, I've got a little panel meter here, which I haven't connected at the moment because for the time being, the way this is fine for me to do things. And let's just look under the hood. You gotta brace yourself. There's a lot of things going around in this power supply. This by far was the biggest project I've done so far. There was lots and lots of wiring to do, as you can see here, for the front panel. You can see There's a whole lot of stuff going around there. You can see here, I've got the batteries here, I've got the batteries there, I've got the batteries there. Obviously they're all locked at the moment. That's for the pass transistors. As I've got the tab selection, there's not much heat going around in the pass transistors. There's not much dissipation on them, so these little ones will do fine. I did a test for 24 hours on them, and they're perfectly fine. They don't get warm or anything like that. I just need to make sure that I select the right tab for the right voltage. And as you can see here, I've upgraded my shunt resistor here. As you can see, before I had something else. Now I've got the precision ones. As you can see here, these are 1%. And this is my voltage reference, as I had before, with the tab selectors for them. I've disconnected the alarm. I didn't need the alarm because I did extensive test on the charger system, and the actual IC on the charger does detect over voltage and does have shut off on it. So I'm not using it at the moment. I just left it here for the time being, because if I wanted to use it later on, then I can just use it there. As you can see here, I've got my charging system over there for selection. We've got the power supply here. We got the tab selector in this one, and I got another tab selector at the bottom. And this is my charger. The thing with this charger is it's rated at 5 volt at 8 amp. These batteries, the charger that I have for charging these batteries, each of the charger can handle up to 1 amp, so that's 6 amp per rail of the power supply. So I decided to use, just have one rail charging, the other rail sit idle, and then once that's done, then it will jump into other rail. I didn't want the whole 12 of the batteries to get charged at the same time, because this wouldn't be able to handle it, because I would need about 12 amps. So this can only handle 8 amp, and I didn't want to push this to this maximum, because at the moment I haven't put any air cooling in this box, in this enclosure. So I just left it at 6 amp. That's perfectly fine. And as you can see here we are. You can see everything at the front panel now, because obviously the light is shining from behind, so you can see all the mess on the front panel. But obviously once you put the cover on, the other way around. So once you put the cover on, everything just, as you can see here, you can see anything. And as soon as you put the cover on and it gets pitch black, then you can't see anything inside the power supply. And you can see here I got these airplane style switches here to switch the load on and off. And obviously I got down here and I got here, and that's it. And let's just check the noise on the output of the power supply. I gotta connect something here. Remember, at the noise that I'm measuring at the moment, this is not the right way of measuring the noise on the power supply, because this forms an inductor and you get all kind of noise coming into it. But as you can see here on the wriggle, I'm on 10 millivolt and there's nothing, there's no oscillation or anything. And if I go up, that's 5 millivolt, there's nothing. This is just the noise that is on the actual scope, which is measuring from this. You can see here, there's nothing there. So yeah, I'm quite happy with this build. I'm glad that it's all finished and it's all over, because there was a lot of issue with this, trying to make this work, and it's all done now. So next project, I'm gonna do a dummy load. I need a little dummy load, because the dummy load that I've got here, as you can see, which I usually use for my projects and stuff, is quite a big thing. As you can see, it takes a lot of space on my desk. Once I'm doing stuff like that, I just need something small that I can do from maybe up to 2 amp or something like that. I don't need this. This can go up to like 7 or 8 amps. I don't need that much for all my projects. So I'm just gonna make something small. What I'm gonna do, I'm gonna have a preset current on it. So with the flip of the switch, or with the selection of the switch, I can go to 1 amp, then I can go to 2 amp. Or like 100 millivolt, 100 milliamp, 200, 300. I can jump scales like that. And what I'm going to do, I'm going to use, I'm going to make my own DAC on it. So I'm going to use a R2R ladder DAC to get the best result. And I'm going to use a rotary encoder, but I'm not going to use microcontroller or anything like that to do the thing. I'm just going to use logic gates and stuff like that. And yeah, so that's the next project, and I've got a few other stuff lined up as well. But for the time being, I'm just going to take a little break because this project, you know, really tired me out, and it took a lot to make it work. And yeah, I got some work commitment as well at the same time. So yeah, thanks for following this this project. If you like the project, give a thumbs up, and until next video, thanks for watching and goodbye.